This is the video for Unit 5, Lesson 1, Simplifying and Multiplying Radicals. The main goals here we're going to be looking at is simplifying a radical expression and multiplying expressions and simplifying. So simplifying radicals is something that we did in Math 2. What we're going to be looking at, though, today is finding not just square roots, but cube root or nth roots for variables and values. So the nth root of a value can be denoted by the nth root of c. So for example, we already talked about in previous classes, like if I'm doing, for example, the square root of 8, what's really happening is like there's an imaginary like little 2 that's like an index that tells us we're doing the square root. What we're going to start to see is what happens if I'm going to do like a cube root of 8, for example, right? So we're kind of taking it past just the square root and looking at when we take the nth root for our term. We're also going to see the product property, which again states that if we have two factors underneath a radical, it's the same as taking the product of those two factors being either square rooted or cube rooted or whatever nth root it might be. So we're going to start to see, obviously, cube roots in here. So what we want to make sure is that, like we thought about with perfect squares, we want to make sure we know what our perfect cubes are. So if we were to list these out, we know 1 cubed is 1, 2 cubed is 8, so 8's actually a cube, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I'll go up to 6 cubed, which is 216. And so these are what we call our cubes. So kind of like we do with perfect squares, we're going to try to break up a value into a product where one of the factors is a cube. So the first one we have here is the cube root of 27. 27 is actually already a cube. So 27 is actually the same as 3 to the third. And if I take the cube root of something raised to the third power, the index and the exponent are the same value, so they're actually it's gonna reduce out, and our value is just simply gonna be 3. So when we take the cube root of something being cubed, we end up with just a whole number or an integer. The next one we have is the cube root of 250. So that one is not a cube, perfect cube already, but we can break it up into the product of two factors where one of them is a cube. So if I go down my list, I can see 216 isn't going to work, but 125 does go into 250. It's 125 times 2. When I do the cube root of 125, I get 5. So the answer would be 5, the cube root of 2. If you forget the 3, that's not technically a correct answer. That would be 5 root 2, which is root 50. So that's a different value altogether. So you do need that index of 3 for it to be correct. For number 3, what we're looking at here is simplifying when we have variables. So this one is the 4th root. So you can see there's a little 4 there of A12, B9, C3. We saw in Math 2, instead of listing out 12 A's and 9 B's and 3 C's, we're really just dividing, right? So what we're doing is we're actually doing 12 divided by 4. So how many groups of 4 can I pull out of 12 A's? I can pull 3 out, and there's actually not going to be a remainder. So I'll leave that for now. If I do the same with 9, how many times does 4 go into 9? I could pull 2 groups of 4 out, and there'll be a remainder of 1. And then the last one, how many groups of 4 can I pull out of 3? I can't pull any, so I would put C to the third. So it's really like just dividing those exponents. And so that would be, so our final answer, it's actually that whole thing, would be A cubed B squared, and then the 4th root of BC3. So that would be our entire answer. For the next one, same idea. So I have value and a variable in the same thing. We can actually break it up into two different problems if we want to, where I have one that just has the value, and then a second radical that has all the variables. And then now we're going to simplify it as just two separate problems. So the cube root of 16, the cube that goes in there is actually 8. So 8 and 2, which is 2 cube root 2. And then for the variables, we're going to do the same thing. So I'm going to write just a little cube root here so I have it. And then we're just going to divide. So how many times, again, I'm working with an index of 3. How many groups of 3 can I pull out of 5? I could pull one group out. And then we're going to be a remainder of 2. Same thing when I have y squared. And how many groups of 3 can I pull? I can't get any because it's too small. And then finally for the last one, how many groups of 6 can I pull out of 6? I can pull 2, and there's not going to be a remainder. So z squared. We're now going to go ahead and put this together. So whatever's outside the radical gets multiplied. So we're going to have 2xz squared. And then the cube root of, and then what's inside is going to go together too. So we're going to do 2x squared y squared. And that would be it. For the next set of examples, it's pretty much the same thing. We're just going to have now multiplication. And we're going to see a mix of cube roots and square roots, right? So for the first one, we're multiplying. And this is, again, we don't see an index. So whenever we don't see an index, that actually means there's a little 2 that's there. So this is actually a square root. So just keep that in mind. It can go back and forth. So for number 5, we're using square roots. So I'm looking for my perfect squares. So the values out front are going to multiply. So I get 15. I'm going to have a radical of a square root, and then I'm going to multiply the values on the inside. So I have a 2 and a 6. That's going to be a 12. And then I'm just going to add the exponents. So x to the 3rd, x to the 4th, that's x to the 7th. We have a y to the 4th. And then I'm going to go ahead and simplify. So we might do the values separately. So root 12 times x7, y4. Root 12 is actually going to be 2 radical 3 because the perfect square in there is 4. And then for this one, again, it's a little index of 2. So I can pull out 3 groups for x, 2 groups for y with a remainder of x. And then finally, anything outside multiplies. So 15 times 2 is 30. So 30x cubed y squared. And then everything under the radical goes together. So root 3x. For the next example, it's the same type of thing. So again, we're talking about cube roots, though. So I see I have an index of 3. I could put them under the same radical. So 6 times 9 is going to be 54. And then I'm going to add the exponents. So x to the 8th, y to the 10th. And then just do the same thing as before. So root 54, cube root, and then cube root of x8, y10. 54 can be broken up into 27 and 2. Or so 3 cube root 2. And then I'm going to divide all the exponents by 3. So we'll get x squared with a remainder of 2. And then y3 with a remainder of 1. And then we can just put them all together at the end. So what's on the outside? 3x squared y cubed. What's on the inside is 2x squared y. For the last two examples, we're just, again, doing multiplication, but it's when we maybe have 2 terms that are given there. or if we have like a 2 term by 2 term. So it's the same thing. We're just doing the distributive property like we would with polynomials, just making sure we're using our radical properties. So root 5 times 6 would be 6 root 5. Root 5 times root 10 is root 50. And then we would just do our best to simplify. So root 50 is 25 and 2. So 6 root 5 plus 5 root 2. And then they're not like terms, so I would leave my answer just like that. And then finally for the last one, same thing. We're just going to do the distributive property. So what's outside the radical multiplies, what's inside multiplies. And so we would get 6 root 25. And then negative 12 root 5. Negative 12 root 5. And then plus 24. This first one can simplify to 6 times 5, or 30. And then we got some like terms. And then finally, we can put the 24 and the 30 together. We would get this to be 54 minus 24 root 5. And that would be our final answer.